In this video session, we're just going to see how to do a PCB layout designing. In the earlier videos, we just saw how to use the schematic editor, and we also practiced a circuit of a dual power supply, a schematic diagram of that, and we have also chosen the appropriate footprints that is required for the circuit we have designed. And now we are just going to convert that into the PCB and create tracks, which is going to be our second stage work. So just double click the PCB layout editor icon. Just wait for a while. Now you could see that your screen is in black, and you may ask why a schematic layout editor icon had a white screen whereas this one had a background of black. It is just due to the visibility purposes. Now you can just see a red color line which acts as a border for the worksheet. Just move towards the down. You can notice a rectangular title block, and there it is mentioned as title as one block, size is another block, date as another block, and the sheet file as another block. Let us just fill all those details at the first. Click the page settings, which is beside the save icon, and choose the required size of the sheet you want, A4 or A3. I'm comfortable with A4. You choose according to the circuit that you've designed, and choose the type of orientation that you require, and mention the date that you're going to submit your project, and mention the title of your project. Let me mention it as dual power supply. Let me write my company name as Tech India and just click OK. Now check whether those details are fed, and yes, my title is written as dual power supply and my company name is also mentioned as Tech India. Now let us go towards the next process. What is the next process? I've earlier mentioned that schematic editor and PCB layout editors are two different editors. Both are just connected by one application. And what is that one application that is going to link both these editors? That is nothing but the netlist file that we have generated earlier. Now let us just read the netlist that we have generated earlier. Just click the read netlist icon that is present above your desktop. Just click that, and firstly check your root directory whether they are mentioned at the correct rate, and it is mentioned exactly correct for me because I've saved my file in the desktop and it is saved as PCB new. The folder inside the PCB new is named as dual power supply, and the netlist that I've created is saved as dualpowersupply.net. After that, if you want to save a report file, you can just click, or you can just read the current netlist. Click that. You can notice a bunch of errors. Just don't mind that. Just click close, and now we have the required footprints that you have assigned earlier on the schematic diagram. Now we have to arrange all those footprints according to our schematic diagram. Let us firstly arrange that. Let us just get a zoom in view of that. First let us take our transformers, press M and move that. Just press R so that your transformer can be rotated. The second thing that is required is the diode. Just press M and move that. Maintain a little distance, and the second diode is also taken. Press M. Make sure that all the components that you're just selecting are closer to each other, so that you might have a smaller PCB. As much as small, it's better. After placing all the 4 diodes, next let's just take a 1000 microfarad capacitor. Just click cancel, click move, place that. Just rotate that so that this plus denotes the positive side of the capacitor, moved a little while away. Next, take the LED, move that and place that below your capacitors. The next one comes your resistor. Just move that and click R and move it slightly below. Next comes the terminal block. Just click move on and place it on one side. Next comes the other terminal block. Chosen one alone. Just choose the entire one. Click cancel. Move that. Next comes this 10 microfarad type of capacitors. It's better if you just move that. Yes, the plus one is on the top, so you don't have to mind. Again, click M and move that. The plus one must be on the bottom side. Now it is correct. Again, move your normal type of capacitor. Click M, move that. Now it is on the horizontal side. Just rotate that and make it vertical so that it might take less space. Just move that. R, again click M and move. Yes, now we have almost completed, but you see we have chosen 3 banana jack pins, and these 3 banana jack pins is quite something huge. So if you don't want, just let us delete that. Right click and just give cut. This one also, just click cut. Now what to do, or where shall we choose the next female connector? You want a female connector, right? We just can't leave that simply. Or click delete. Now almost all the things are deleted. Now we just want 3 female connector pins. Now let us choose that. In the add footprint icon, which is present on the right side, 4th icon, just click that and place your cursor anywhere and just click select by browser. And instead of 3 female connectors, let us choose a terminal block. In the terminal block, we can also choose a Bonnier 3-pin connector so that it has 3 pins, 2 pins with 12 voltage and 5 voltage and 1 pin with ground. It is even more sufficient rather than using 3 female pins because it requires a lot more space. Since PCB boards should be as small as possible, let us just see its 3D view. It is exactly the one we wanted, so let us just select that. We have chosen that. Let us just rotate that, and now let us move that. Now we have to change the diode symbols because only 2 diodes are faced in the same direction while the other 2 diodes are changed by its position. Just let us move that. The 2nd and the 4th diodes are chosen, and let us rotate that. Let us just move that. And now we have almost completed our connections. What must we do after completing our connections? And now let us just see the connections are given already, and you can see that there is a white line connected. It confuses you so much, right? Now how can we just avoid all those white lines? Here on the left side, 6th icon, you can see hide board rat's nest icon. Just click that so that all the white lines has just disappeared just like that. And now we can just see the 3D view Yes. Now let's just recall what are the components that we have applied footprints used over here. First one is the transformer, and we've used 4 diodes, and we have also used radial type of capacitors. Radial type of capacitors have both positive and the negative sign. This one, yes, this silver color represents the negative line, and in the diodes generally we have two methods to see the positive and the negative side. One side is that whenever there are two pins for the LEDs, right? When one pin is taller and the other one is shorter compared to it, the taller one is represented as a positive one, while the shorter one is represented as a negative one. The other type, how to represent the positive and the negative type of LED, is that the round is not completely filled, and here there is a slight cut over that. The slight cut is just to denote the negative part of the LED, and we have used an axial type of resistors, and here we've used two type of regulators. One is a 7812 regulator and the other one is a 7805 regulators, and here also we've used two radial type of capacitor with 10 mu farad capacitors, and the negative part are facing each other, and the disc type of capacitors does not have positive or negative sides, and instead of connecting 3 female connectors, we have used a 3-pin terminal block so that it may reduce the size of our PCB boards, and we have also arranged according to the schematic diagram. Let us now name all the components. Yes, now they are not named at the proper rate. Just double click that and name that as D1, and just place that at the center part, and this D2 also must be placed at the center part. D2, just move that D2 at the center part. D2, D3, just click that and move, and the D4 is also moved inside the diodes, and here we have used the C1, that is the capacitor one. Just double click that and mention that it is a 1000 microfarad capacitor, sorry, and just click OK, and just press M on the keyboard and place that inside, and here the D5, just move that inside, and the R1, just click, double click that, move that, name that as an 1K resistor, and here the type of regulator used must be mentioned. Just move that, place it inside. Now you can just mention that as an L7805. Move that firstly, keep that inside, and rename it as an L7812 regulator. And now here we have used our third capacitor, just name that inside, and the type of capacitor we have used is 10 microfarad, name that, just move that and rename that as 10 mu F, move that one just above, This one is 0.1 type of disk capacitor. This one also is the same kind, 0.1 mu f of disk type capacitor, and here we have used our just move that inside. Just name that as in connector. Name the 1 2 3 instead of pad number 3. You can just name that as 12 volt. This pad number 2 can be named as 5 volt. This pad number 1 can be named as the ground. Yes, now we have just completed naming all the footprints. Now we have just need to remove the pin dimension, so that now we are just going to click the FAB icon that is present in the right side, the last below icon. Just disable that FAB icon. Now you can notice that our diagram looks at a neat pace. So now just click silk layer, F silk. Now we can just notice only the white side, and all the things that we have written are now disappeared. Why is that even so? Let us just notice the 3D view after removing all the things. You can notice these type of things, right? So the silk layer is missing over here because we have not disabled the F silk. Just let us enable that and let us notice the changes. And here I hope you have seen the changes. Just click, and those white things denote the silk layers. These white things denote the FAB silk layers. So what is the next thing? The next thing is that now we are just going to create the track. There are totally two layers. One is the front copper layer, while the other one is the back copper layer. Generally we are just going to generate only the back copper design. Why is that even so? You know what, whenever we are going to design a single layer PCB, during that time our connections are given only at the back side of the PCB board and not at the front side. Not only that reason, there is another reason also. Whenever you use a throw-hole resistors or any throw-hole components, we generally prefer only single side PCB. So whenever we are using a single side PCB, we're just only using the back side copper rather than using the front side copper. So now we are just going to just create our own tracks. Whenever we use a double side PCB, we tend to use a front copper layer. Now the wire connections are clicked, that is the root tracks. After clicking that, just draw that, and yes, just click and escape. The color is something different than what we expect. Let us just see that in a 3D view. You could notice that there is a color present over here and it is something green. Something is wrong in this circuit diagram. So what is wrong in this circuit diagram? Yes, we have to use only back copper, since we are just going to give connection only in the back side, and the PCB that we have designed is a single side PCB or single layer PCB, and we have used almost only throw hole components, and hence just click back copper and again click that. Now again let us just go to the 3D viewer. Now you can see the change. This one is the front copper Yes, this one is a front copper layer. This front copper layer is now, it is shown in the green color, whereas here is the back copper layer that I have drawn. You can notice the changes. One is shown on the back side while the other one is shown on the front side. We are just going to give the connections at the back side of the PCB board only, so that it is better if you just prefer the back copper one. So let us just firstly delete both the connections. Sorry, just click and undo. Just click delete. Just click, sorry, delete, and once again delete that. Now after clicking back copper, again just click root tracks. After clicking root tracks, just place the cursor at any part of your sheet and just right click your mouse and click interactive router settings. There just click the highlight collisions. If it is already there in the highlight collisions, just leave that as such. If not, just change that into the highlight collisions. So why are we even choosing the highlight collisions? Before drawing the clock, you can just add the highlight collision from one component to the other one except one, so that your track comes exactly. After that, except the highlight free angle mode, just click all the other things, jump over obstacles, remove redirecting tracks, optimize the pad connections, smooth drag segments, and allow DRC violations, and just click OK. After that, now see, draw that, again click root tracks. There is some problem. Check whether everything is enabled. Yes. Now I've just made a mistake. What is that? Don't you feel something odd in this diagram? Yes. Let me just reveal what is the mistake that I've done. That is nothing but the track width is something very low. So what is the track width that I've drawn now? It is only in 0.250 mm, which is even more lesser than 1 mm. So how much short it will be? Let us just change the width of our track. How shall we change the width of our track? Just click setup, click design rules, click global design rules, and mention the required track widths that you want. Let me just start from 2, 1.75, 1.5, 1.25, 1.75, 0.5, 0.25, and click OK. Now let us just choose the track width as 1.5. Just click escape. Let us just delete the previous track that we have drawn because it is at the wrong track width. Maximum this 12 volt DC can have a track width up to 1.25. So now let us again click the root track widths. Now let us give the connection. We have given from this one, again over here, this one, completing again from this corner, just connect it. from the first diode to the second one. Here I've just made a mistake. Always make sure that your tracks must not be drawn at a distance of 90 degree. Whatever might be the condition, make sure of that. Here also I've made the same mistake. While you are drawing that, don't make the same blunder. We have completed, and now from the second part we are just going to connect it to the second part of our resistor. After completing, just click that. Now from one side of the capacitor, again we just going to connect it to the another part of the resistor straightly. Now we have completed this connection. From starting end of the resistor, just connect it to the 7805 regulator. Just complete that. After that, from 4 diode again complete that. From this part again start your connections and connect that to the sorry, I've just made a mistake. Just delete the part. Again just select your two tracks. Second one, from this ground again to the second part of the ground, again press that. Now from this end you just going to correct. From one end starting, you're just going to connect to the other capacitor. From this capacitor you're going to connect. If you're confused with these connections, just connect as per the schematic diagram, the one which I am doing. We have completed almost our connections. From one capacitor again we are connecting to the other capacitor. From this capacitor also we are connecting to this capacitor. After completing, from this capacitor we are connecting to this capacitor. Again from this capacitor we are connecting to this capacitor. So now the first part of the capacitor is connected to the 12 volt and the second part of the capacitor is connected to the ground. And here the last part of the capacitor, the last part of the capacitor is connected to the 5 volt. We have just completed our circuit by just connecting the tracks over and over, and now let us just have a short recap. That is, we have two main important points to be remembered. The first one is that whenever you're drawing a track, it must never be 90-degree angle and always having slight inclination at each of the track that you're drawing, or else draw a straight one. just like that, or just have a short inclination like that. If you're drawing 90 degree, then it is considered to be a wrong track. And the next thing that must be remembered is that the connection can be given even inside the components. That is not considered to be a problem because there is no component placed in between them. After just giving the tracks or connecting the tracks, just click save icon and just see the 3D view of that. Just click view, 3D viewer. Now we can just notice the changes or the connections that we have given. Since we have given the connections using the back copper, so that our connections would be visible only at the back side of the board. Since we are using the throw hole capacitors, we are just going to give the connections only on the back side, and the PCB that we are going to design is just a single layer PCB. We are using the back copper instead of using the front copper. Just keep that in your mind. And if you are just using a double layer PCB, there only you need the front copper, and now back copper is more than enough. You can notice that there are more edges or left out spaces. You can just cut all those edges using the edge cut icon. How is that so? Let us see. Now just click the edge cuts in the right side icon. After clicking that, just click add graphic lines. After clicking that, move towards your left side and there are so many icons there. Just click the change cursor shape. After that, you can see 2 white lines visible on your desktop. Just start clicking from the place where you want. I think there is some problem. Start there. Make sure that you're drawing a straight line without any mistake. Draw that slowly. And now we have just completed our yellow line. That yellow line just denotes the edges, and even the edge cuts can be done by the other shapes, that is using the circle. Just see that in your 3D view. Yes, here it is. If you don't want, just delete that. Click delete, and there are more other options. If you just want to add a graphic arc also, it is possible. See, now we can just do that according to your wish. It is not compulsory. And now we have just completed our edge cut process, and the next process is to just label. Just click and escape. Now you can just see that there are so many remaining spaces over at the bottom of our PCB board. In order not to waste those spaces, we can just type our company name. For typing that, we have to first select the layers. Let us click F-Silk layer so that the name of our company shall be visible at the front side of our PCB board. Let me just name my company name as Thick India and just press OK and click that at the bottom side. If you want, even you can click the back copper and click add text icon, and again let me name it as Thick India. You can notice a change. It is in mirror shape. Why is that in the mirror shape? Let us check that in the 3D view. Since I've just used the layer of F-Silk, this Thick India is in the front shape and it is present in the front side of the PCB. If I just turn over the PCB side, since I've used the back copper layer, the Thick India is visible or written at the back side. Since it is in the back side and it is written on the front side of the PCB, the thick India is mentioned at the mirror shape. Now after completing all these processes, just click save. And in this video we have learned how to draw tracks, how to draw the edge cuts, and how to just name our company inside the PCB board, and I just hope you're clear with it without any doubts.